In this video, we will see properties of numbers. We will see closure property, commutativity, associativity, distributivity, and identity property. First, we will see closure property. A set is closed under an operation if performing that operation on members of the set always produces a member of that set. So that means the closure properties, the closure property applies to a set of numbers and for a particular operation. Suppose we have a set of number and we do an operation addition on the members of that set. So if we take any two numbers and add them, and as a result what we get is a part of that set only. So for any two numbers, the resultant number is also part of that set. So that means the set is closed under addition. So let us understand this through an example. We take a set of numbers A1, A2, A3, A4 and it goes on the set. So we take any two number A1 and A4 in the instance we have taken and we do addition operation on them. So we add A1 and A4. And in place of A1 and A4, we can take any of the two numbers of that set. So as a result, as a result of this addition, what we get is a member of that set only. This A1, A2, A3, A4 is this set. The resultant answer is a member of this set only. Then the set is said to be closed under addition, because the result what we get after addition is also part of that set. And let us take two numbers and do a subtraction operation. For instance, let us take A2 and A6 and we do A2 minus A6. So as a result of this operation, if we do not get a member of that set, so for suppose if we subtract any two numbers, if in case some of the numbers we get the answer which is part of that set, but in few cases or even in one case if we do not get, if our answer of subtraction is not what the result what we get is not part of this set, then the set is not closed under subtraction. So the closure property applies to a set of numbers and for a particular operation. The next property is commutativity. Commutativity states that the numbers on which we operate can be swapped or interchanged without making any difference to the answer. So let us understand this through an example. Here we are doing 6 multiplied by 2. So we are doing multiplication of two numbers. So what does 6 multiplied by 2 means? We have already seen in the multiplication. So this means we are taking 6 steps two number of times. So here we can also see through the depiction in the diagram that we are taking 6 steps twice. So in all what we are doing is we are taking 12 steps. Now let us interchange the number. So 2 comes first and 6 comes later. So now we are doing 2 multiplied by 6. So now we again can see in the diagram what we are doing is we are taking 2 steps 6 number of times. So that means again what we are doing is in 2 multiplied by 6 we are again doing 12 number of steps. We are again taking 12 number of steps. It's just that the orientation of steps is different. We can see the orientation is only difference, but the total number of steps are same. So that means commutativity holds true for the multiplication operation. So it is true for the multiplication operation. So this is because even if we interchange the numbers in multiplication, like we did 6 multiplied by 2 and then we do 2 multiplied by 6. Even on the interchange of numbers, the answer remains the same. So now we will see whether this commutativity holds true for division also or not. So let us take an example of division. So we take 10 divided by 5. So that means 10 counting numbers are divided by 5 numbers. So let us take an example of 10 balloons. So we have to divide 10 balloons among 5 people. So for 5 we are taking people and we have to divide 10 balloons among 5 people. So when we start dividing, like over here, as a result, what we get is each of the person is getting 2 balloons. So each one is getting 2 balloons. So that means the answer is 2 for this operation. 10 divided by 5, that means each one is getting 2. So answer is 2. So now let us swap the digits. So now we will do 5 divided by 10. So now in this case, we have 5 balloons and we have to divide these 5 balloons among 10 persons. So now if we want to divide 5 balloons among 10 persons, each one of the person would not be able to get even one balloon, because if we give one balloon, then these 5 balloons would get over by giving them to the first 5 persons. So if we divide 5 balloons among 10 people, only first 5 persons would get one balloon each. So the answer is less than 1. Each person is not getting even one balloon. So the answer is less than 1. So we can see that commutativity does not hold true, because when we swap the digits, the answer gets changed. So commutativity does not hold true for division operation. And this is just the few examples we have seen. We will see this commutativity for addition and subtraction also when we discuss these properties for whole numbers in a different video. Now we will see the property of associativity. Associate means grouping or to group. And the property of associativity states that rearranging the parentheses or the brackets in an expression having two or more occurrences of same operator will not change the result. So this property is with respect to the operation. So let's first see the example of addition operation. So we have equation 8 plus inside the bracket 2 plus 3. And we have one more equation inside the bracket 8 plus 2 and then plus 3. So we can see over here the placement of brackets have been changed in the second equation. If we get the same result from these two equations, then we can say that addition operation is associative, as rearranging the brackets doesn't change the result. So let's draw the number line, and in the starting, we will start from 0. In the first equation, we have 2 plus 3 inside the bracket. So first we will do that, because we operate the operation inside the bracket first. So first the person will move 2 steps and then 3 steps. So the person has reached to digit 5. Now in this 5, 8 steps will be added. So the finally person reaches to 13. So our answer of first equation is 13. In the second equation, first we will do 8 plus 2, as this is inside the bracket. So the person reaches to 10. Now we will add 3 more steps and the person again reaches to 13. So from both these equations, we get the same answer, because while adding the digits, we are actually adding the count of that digit. The count of one digit is not dependent on the another digit. Whether we add that count in the starting or in the end, the count of 8 remains 8 and 2 remains 2. So we get the same answer. Therefore, addition is associative. That is, rearranging the brackets doesn't change the result. So next we have subtraction operation. We have equation 6 minus 3 inside the bracket and minus 2. And second equation 6 minus inside the bracket 3 minus 2. So placement of brackets have been changed. In the first equation, we have 6 minus 3 inside the bracket. So first we will do that. So we will first move 6 steps forward and then take away 3 steps. That is, move 3 steps backward. So now the person reaches at 3. Now again subtract 2. So the person reaches at 1. So answer of first equation is 1. In the second equation, first we will do 3 minus 2 as this is inside the bracket. So answer of this operation is 1. Now we have to subtract this 1 from 6. So we will move 6 steps on the positive side and then take away 1 step. So the person reaches at 5 in this case. So from these equations, we got different answers because in the second equation, the 2 inside the bracket became positive. That is, minus minus became positive. So we move 2 steps on the positive side. So therefore, we can see subtraction is not associative. So we have seen for addition and subtraction, and for multiplication and division, we will see while discussing the properties for whole numbers. Now we will see the property of distributivity. We know that distribute means to divide something, and distributivity means to divide the given operation on numbers. But we don't divide all the operations. We divide only those operations which interlinks the numbers. Here we will see the example of addition. In addition, we have 2 or maybe more than 2 numbers. But in addition, the second number is not dependent on the first number. Irrespective of what our second number is, if our first number is 3, then we will start from 0 and move 3 steps. And second number can be either 1 or 5 or any other number. Accordingly, we move the steps thereafter. Similarly, in subtraction, the first number is not dependent on the second number. Suppose if our first number is 7, then we will move 7 steps and thereafter subtract from there according to what number is there in the subtraction. So in addition and subtractions, numbers are not interlinked. Therefore, these operations do not get divided over the other operations. Now we will see regarding the multiplication operation. So we have 4 multiplied by 3. We have already seen that multiplication is repeated number of addition. So that means number 4 get added 3 number of times. So the multiplication is actually linking both the digits. The number of places, the number of 4 places we move depend on the second number, that is 3. So we will move 4 places 3 number of times. And if 4 multiplied by 5 is there, then we'll move 4 places 5 number of times. So multiplication operation actually interlinks the number. So now we will see how it gets distributed. So now we have in the diagram 12 stars. The 4 stars are getting repeated 3 number of times. So now how we can distribute it is, we can take 8 stars separately and we can take 4 stars separately. So now 4 multiplied by 3, those actually 12, can be represented in this way. So the 8 stars can be represented by 4 multiplied by 2. When we multiply 4 by 2, we get 4 stars or triangles twice number of times. So we have over here 4 triangles 2 times we have, and in the next we have 4 triangle 1 time. So we can write it as 4 multiplied by 1. Now we can expand 4 multiplied by 3 as equal to 4 multiplied by bracket open 2 plus 1. So we can split 3 into 2 plus 1. So what is happening over here is, when we multiply 4 with 2, we get this 4 into 2. And the 4 into 1 we get because of when 4 multiply with 1 inside the bracket. And because we have plus sign inside the bracket between 2 and 1, we get this plus sign. Between 4 multiplied by 2 plus 4 multiplied by 1, this plus sign is because of the plus sign in the bracket. So the number 4 is getting distributed. because of the multiplication sign, it is getting distributed over 2 and 1. So it is equal to 4 multiplied by 3 equal to 4 multiplied by 2 plus 1 inside the bracket is equal to 4 multiplied by 2 plus 4 multiplied by 1. So this is actually distributivity of multiplication over the addition sign, because inside we have addition sign. So multiplication is getting distributed over the addition sign. So in case of multiplication, we have distributivity. We have already seen the distributivity of multiplication over addition. Now, what if we have subtraction sign inside the bracket? Whether the multiplication will get distributed or not, let us see. So we will take 4 triangles, and this can be represented as 4 multiplied by 1. Now, these 4 triangles can also be written as 8 triangles minus 4 triangles. So what we are doing are, we are subtracting 4 from 8. So we'll get what we have initially, that is 4 triangles. Now 8 triangles can be written as 4 into 2, because 4 triangles are getting repeated twice. And what we are subtracting 4 triangles, these can be written as 4 multiplied by 1, because 4 number of triangles are getting repeated once. So now we will expand, or we will include the bracket in the initial equation. 4 multiplied by 1 can be written as 4 multiplied by, inside the bracket, 2 minus 1. So 4 multiplied by 1 is equal to 4 multiplied by, bracket inside the bracket, 2 minus 1. So now 4 multiplied by 2 is what we get when 4 get multiplied by 2 inside the bracket. So when 4 outside the bracket get multiplied by 2 inside the bracket, we get 4 into 2. And 4 into 1 we get from 4 when multiplies by 1 inside the bracket. And we get minus sign over here in yellow because we have minus sign inside the bracket. So we can see that 4 outside the bracket is getting distributed over the digits inside because of the multiplication sign. So this is distributivity of multiplication over subtraction. So we have seen that multiplication get distributed over addition and also subtraction. So now we will see distributivity in case of division operation. So we'll take one example. Over here we have 8 divided by 2. So that means we have to divide 8 number of items into 2 parts. Or we can say we have 8 flowers and we have to divide these 8 flowers among 2 girls. So now we'll give 1 flower to each girl one by one. And at the end, each of the girl has 4 flowers. So our answer would be 4 because each of the girls has 4. So when we divide 8 number of items into 2 parts, so each part has 4. So initially we had 8 flowers, and when we divided those 8 flowers among the 2 girls, each of the girl got 4 flowers. So our answer was 4. So now let us take 8 more flowers. But this time we will split them into 2 parts. We will first take 6 flowers and then we'll add 2 more flowers. So first we will divide these 6 flowers among the same 2 girls. So each of the girl would get flowers one by one, and in all both of the girls get 3 flowers each. So our answer of this division 6 by 2 is 3. And now we have 2 more flowers. Let us also divide these 2 flowers among the 2 girls. And each of the girl would get 1 flower. So result of this division is 1. That is 2 divided by 2 is 1. So we can see that the result is again the same. Initially we got answer 4 and then we split the 8 flowers in two parts, that is 6 and 2. So again our answer was 4. 3 plus 1, that is we got 4. So what is happening over here is 8 by 2 can be expanded into 6 plus 2 divided by 2. So the 6 inside the bracket, when we open the bracket, then what we do is 6 divided by 2 is getting represented by 6 divided by 2 in the green when we divided 6 flowers among the 2 girls. And when we divided 2 flowers among the 2 girls, that is 2 divided by 2 in the green, is getting represented by, when we open the bracket, 2, the 2 inside the bracket, which is written in blue, get divided by 2. And the plus sign between 6 and 2 inside the bracket is represented by the plus in the green. The plus which we used while we split the 8 flowers into 2 parts. So what is happening over here is we are splitting 8 into 2 parts and the division is getting distributed. So this is called distributive property of division. And just like in the case of multiplication, this also applies when we have minus inside the bracket in case of division. So if there is 6 minus 2 divided by 4, then this also get applies. So initially then we would have 4 divided by 2 equal to 6 minus 2 in the bracket divided by 2. But this applies, we have seen that this applies only when we split the number which is being divided. When we split the number which is being divided, that is when we are splitting the numerator. So 8 is called numerator, or it is also called dividend. So when we are splitting it, this distributive property of division applies. Now we will see whether the distributive property get applies if we expand and split the number 2 over here. The number 2 is dividing the number 8. The 2 is called denominator, or the number which the numerator is being divided by. So what if we split 2? We can write 8 as 8 divided by 2 as 8 divided by, inside the bracket, 1 plus 1. So will the distributive property applies, or will this be equal to 8 divided by 1 plus 8 divided by 1? So can we write 8 divided by 2 equals to 8 divided by 1 plus 8 divided by 1? So 8 divided by 1, what does it actually means? It means that we have 8 flowers and we have to divide these 8 flowers among the one person or one girl. So we are actually not dividing, since there is only one girl, we are giving all the 8 flowers to this girl. So the answer is 8. And then there is plus sign, so we'll plus it. And again the division is happening, 8 divided by 1. So that means we are dividing again the 8 flowers into, and we are giving those 8 flowers to the one girl. So that means again that same girl would get 8 flowers. So in all what we are getting is 8 plus 8. So that is we are getting 16. So this is not equal to the result what we have got by dividing 8 by 2. So 8 by 2, when we divided, we got 4. But what we are getting over here is we are getting 16. So there's a difference in answer, because we have actually changed the number of person in which the items are being divided. So earlier the number of persons were 2. When we split and when we expanded the digit 8 and split it into 2 parts, then again the number of persons in which those items were being divided remain the same. That remains 2. But now when we are expanding the digit 2 and splitting it, the number of persons in which the items are being divided has changed. It has changed from 2 to 1. So that's why the division has changed and the distributive property does not apply in this case. So we have seen that distributive property of division works only when we distribute the division over the numerator. That is, we expand the numerator and distribute the denominator over the numerators. Now we will see identity property. In this we'll see additive identity and multiplicative identity. So let us first see additive identity. So we'll see this through an example. Let us take this equation. 6 plus 0 is equal to 6. So what we notice that when we add 0 in any number, in this case we have added 0 in 6. So what we get? The same number, that is 6. And let us take one more equation. So 123 plus 0 gives 123. So we can see from these two equations that when we add 0 in any number, we get that same number. In the first case, we got 6, and in the second case, we got 123, the same number. And in other cases also, when we add 0, we get the same number. So 0 is called additive identity. The number 0 is called additive identity because when we add this number to any number, we get that same number. And similarly, we can see this equation, 9 minus 0 is equal to 9. So when we are subtracting 0 from any number, we are getting the same number, that is 9. And one more equation, 250 minus 0 equal to 250. So similarly, in the subtraction case also, when we subtract 0 from any number, we get that same number. So 0 is also called subtractive identity. Because when we subtract 0, we get the same number. We get the identical number. So it is also called subtractive identity. Next is multiplicative identity. So let us see this example. We have 4 multiplied by 1 equals to 4. So what is happening over here is we are multiplying 4 with 1. So that means we are repeating 4 just only once. So we get that same number. Similarly, we have 79 multiplied by 1 equal to 79. So we have seen that when we multiply, we start from 0 and the number of places we move is the number what we get after repeating the initial number. So we have 79 over here and in the first equation we have 4 and we're repeating those number only once. So when we move from 0, 79 places and we repeat that only once, so we reach to the 79 number. So what we have seen is when we multiply a number with 1, we get that same number. So 1 is called multiplicative identity because we are getting the same number. And similarly, in the division also, when we divide a number by 1, so that means we have, over here we have example, 8 divided by 1 equal to 8. So that means if we have 8 items and we have to give those items to only one person, so we will give all the 8 items. So that one person would have all the 8 items, so our answer would be 1. Similarly, when we divide 72 by 1, we get 72, or any number by 1, we get that same number because we are giving all those items to that one person. So our answer is the same number, that is in the first case 8 and the second case 72. So similarly, we can see that 1 is also called divisive identity. So 1 is multiplicative identity and is also divisive identity because when we multiply a number with 1, we get the same number, and when we divide a number by 1, we get that same number again.